Hi guys, hope all of us are doing fine. So today we are going to look at one of the basic concepts in organic synthesis, and this basically is going to be the concept of Oxymercuration-Reduction. And in this particular process, we had mentioned earlier that we can be able to achieve different functional groups through the various reactions that we have mentioned under organic chemistry. And basically, we're going to see that the concept of organic synthesis basically assist us to predict some of the product species that we're going to achieve through various reactions. And sometimes it is, of course, difficult to predict the outcome or the result of some of the reactions that we're going to see later. And in this case, we are forced to use, or rather we are therefore required to use specific reagents which are going to be assisting us to achieve basically a desirable product. And basically we're going to see that this particular case for the Oxymercuration process there, and therefore it's going to provide for us a more reliable way of trying to predict the products which are going to be formed. Now, this is in conjunction with the two videos that were discussed on the hydration, or rather the formation of alcohols due to interaction of alkenes and water. And then next we had looked at the concept of the reaction between alkenes and alcohol, which basically led to the formation of ethers and other products. So in this case, for oxymercuration, we're going to consider the reaction between this particular case for the alkenes and an what we refer to as organomercury. So we had said that we're going to use some of the reagents, so basically organometals. We had said that basically the formation of the specific functional groups or the carbon bonds with other compounds is going to be achieved through the involvement of an acid as a catalyst and some of the transition metals or transitional metals that were mentioned. So in this particular case, we are going to consider organomercury as one of our reagents to try and figure out what are some of the products which are going to be formed. So therefore, this process of oxymercuration in alkene is going to occur in aqueous tetrahydrofuran. We had mentioned about the concept of a heterocyclic compound. So this is an heterocyclic compound that we're going to, of course, see from this particular case. So I'm not going to go into details about that, just a mention about that specific reagent. So if the process of in this particular case, if this is going to be an interaction between alkene and, of course, an organometal in tetrahydrofuran, then therefore we are going to expect this particular process to undergo what we refer to as a reduction. And therefore, after reduction, we're going to involve another reagent that is going to be, of course, sodium borohydride. And this is going to assist us, of course, in trying to see how the second step is going to facilitate a complete reaction to form a desired product, as we have mentioned. So therefore, I'm going to illustrate this one using an example, having mentioned these specific reagents that we're going to use. So if we have an alkene, a functional group as such, and therefore we can be able to give just a summary of the reaction that is going to take place. And we have mentioned that first we're going to have an organomercury, which is basically mercury acetate. And this in mercury acetate, we're going to see that it's going to be combination with tetrahydrofuran, and of course we're going to see that that is going to be involving water. So therefore we're going to have the second step for sodium borohydride that is going to be given as such. So this is going to lead to the formation of an alcohol. And therefore, as we had mentioned, basically we can be able to illustrate this one using the reaction mechanism. And our main objective is to try to obtain the desired product, of course, which is going to be predictable. So if we try to show the specific rearrangements and reaction mechanisms which are going to be involved in this particular reaction, and therefore we can just give the similar example for an alkene that is interacting with this specific organomercury, and this is mercury acetate. So therefore it's going to have those two specific molecules attached to the mercury as such. And from this I've illustrated this pair of electrons which are just appearing in this particular case. So we're going to see that this is going to form the interaction between this is going to form what we call an intermediate, which basically is going to be a cyclic form of that particular nature. So therefore the interaction between that one is going to give us this particular intermediate that is going to have a formal charge for mercury at this specific point. So therefore we can be able to illustrate this one in just two specific steps, whereby we're going to have this particular element or rather this particular compound, which is an alkene, interacting with this one. So I can be able to transfer this one, just try to show the bonding. So just write them as this. So we're going to have that one, of course, this is going to have a formal positive charge due to the influence of those two negatively charged acetate molecules. So therefore we're going to see that the alene molecule, as we said, that the electronegativity of course is going to vary from different molecules. So therefore we're going to see that this one is going to attack on that mercury, and this is going to act as a leading group, and this is going to lead to the formation of a carbocation, or rather an intermediate that is going to involve that particular case for formation of that particular case of this intermediate with a single acetate group as such. And therefore from this we're going to see that this is going to undergo a rearrangement, as we had said earlier, so that we can be able to see that the formation of a 30-degree carbocation, which is more stable than the second degree, which is more stable than the first degree. So this is going to experience the same influence as we have said, which is going to facilitate the rearrangement process that is going to result in the formation of this cyclic form of that intermediate. So from there we're going to see that this is going to lead to a reaction, whereby we have mentioned that one of the reagents that is going to be involved in this particular case is water. So therefore from this particular case we're going to see that there's going to be an interaction with a water molecule, of course, which is going to attack at this specific point, which, as we said, that the third-degree carbocation is more stable. So therefore it's going to attack at that particular point, and therefore this bond is going to move in that direction. So from that particular case also we're going to have a subsequent intermediate. So I'm going to have to put this one in this particular case so that we can be able to have that complete set of reaction. So therefore we're going to have this one illustrated as such. This is HOC, and we are given. And therefore we're going to see that this water molecule, we're going to have it at that specific point, positive. And then we are going to have this one attached. There are two hydrogens that are going to appear at this specific point. So we're going to have one hydrogen at that specific point and another one at that point. And therefore this is going to have a formal positive charge. I hope it is legible from your end. And a subsequent water molecule is going to pick on that one proton, and the bond is going to move to stabilize that intermediate. So therefore from this one we are going to have this particular next product, which is going to be, of course, a more stabilized one, which is going to appear as such. But we can also see that from, if we decide to have an alcohol, as we had mentioned, that we decide to have an alcohol through the Oxymercuration-Reduction process, which is more reliable, then therefore we have this particular organomercury steel group that is attached at this specific point, and the role of the sodium borohydrate then therefore is going to come handy in this particular case in order for us to achieve the leaving group for this organomercury group. So therefore we are going to involve the reaction of so I'm going to create a small steel passage there so that we can be able to have the second. So first we had what we referred to as organomercury tetrahydrofuran, and then water in this particular case. So the second case, we said that we are going to have sodium borohydride that is going to be involved in this case, and it's going to assist us achieve the removal of this organomercury group. And therefore the end result is going to be an alcohol, which is going to be illustrated. This is an al group, of course, we can just leave it as such. We're going to have an alcohol illustrated thus, which was a specific end product that we were supposed to, of course, obtain from this particular case. So if you try to trace this specific kind of a reaction, this is a direct, of course, a reaction from this specific point, which is going to result in the formation of an alcohol, but the formation of an intermediate one due to stabilization that I've mentioned to different levels of degrees of this particular carbon for the third degree, second degree, and first degree. Therefore, we're going to have a preference for the third degree, which is more stable, and therefore leading to the formation of this cyclic form of this intermediate. And the water molecule is going to attack at this specific point. It's a third degree carbon, of course, and this is going to lead to the formation of this intermediate, which is going to interact with a water molecule at this specific level by picking a proton, and this is going to move to stabilize this particular charge. And therefore, due to our desire to have an alcohol as our end product, therefore we'll have to remove this particular group. And then I mentioned that this is the role of the sodium borohydride that we're going to see take, of course, a role in that particular case. Now we're going to look at the second case. We had said that we can be able to have an alkene as the first group, which is interacting with water to form an alcohol, or reacting with alcohol to form ethers. So if we decide to have an ether, then therefore we're going to have perhaps a second or rather different reagent apart from the organomercury and then the water and tetrahydrofuran in that specific case. But the variation of those reagents, of course, is going to be a slight one, of course, which is going to lead to the formation of an end product that is an ether instead of an alcohol. So basically in this case, I'm just going to mention the reagents that can be used, and this is going to assist us in trying to figure out how we can achieve a reaction mechanism, which basically is going to be similar to the one that we have said with a slight variation for the reagents. So suppose we have this is an alkene that is going to, of course, undergo that transformation to form what we call an ether. So we can be able to illustrate that one as such. And if I try to give this one, we said that for the first case, for the formation of an alcohol, we had organomercury, which is a mercury acetate. And in this case, for the first reagent that we mentioned, we're going to have methanol, which is going to be used instead of water. So therefore, we're going to see that this is going to form a methoxide group in this end product instead of a OH. And therefore, for the second case, to have this living group for the acetates as a living group, then therefore we're going to have sodium borohydride, which is going to act in the second step in order to achieve the end product by having this one act as a living, one unit of this one act as a living group. So the concept of oxymercuration therefore comes in handy as a way of trying to achieve a specific end product whenever we are trying to perform some of the reactions in organic synthesis, as we have just illustrated in this particular case. So from this also we are going to look at different mechanisms that are going to be involved, especially whenever we're talking about the concept of perhaps we have talked about this is organomercury. Now we're going to have other complexes like alkyl mercury acetate, which are also going to be involved in the reaction with different parts of these specific compounds. And therefore we're going to see a role of radicals which are going to be involved in this specific case, and which of course are going to assist us in trying to find some of the end products that we desire to achieve from these organic reactions. So that one we shall have it in our next discussion. And of course we are going to see, now that we have looked at the reaction of the alkenes, we're going to also to look at the reaction of alkynes and try to see the difference that exists between these specific processes. So we shall stop there for now. So catch us in our next video as we look at the other reactions which are going to involve alkynes and the subsequent products that are going to be formed. So that is it for now. Catch us in our next video. Kindly go to YouTube and search Ernest Sciences and Mathematics TV channel. Subscribe and engage us on the comment section so that we can be able to have healthy discussions and have some of the input from the various videos that we're discussing. So that is it for now, guys. Bye. God bless you.